All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up where we left off on the last stream, which was essentially troubleshooting and bug fixing with our new K3D format. But before we get into that, I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Alazaran, followed by our partners, Gerbolis Inc. and Matt Osgard. They are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. I greatly appreciate it, and it helps me cover the cost of running this channel, things like software licenses, hosting fees, eventually assets, things like that. So thank you all very much for that support. It is greatly appreciated. With that, I would also like to give a big thank you to all of you guys, the viewers, whether you're joining us here on the YouTube side or the Twitch side, or if you're catching the VOD after the fact. Thank you guys very much for being here. Without you guys, the channel and the project would not exist. So thank you all very much for being here. I appreciate each and every one of you guys. Apotham, good to see you. How are you doing? Eyeless42, good to see you as well. RCW, hello. Great to see you as well. All right. So, Ruche, of course, thank you for the hello there. And welcome. So, what we are doing tonight is we're kind of continuing where we left off last night in troubleshooting, sort of loading. I think we got all of the serialization stuff done. Tonight we have to actually look at the deserialization stuff, having to do with K3D models. And so I had run into some issues at the end of the previous stream regarding the binary string table. And so what I started doing was I actually started writing some tests around that. If we go to our test main, I've created some tests around the binary string table. Just to sort of knock out some issues there, and we did actually find a few things offline. So essentially all this does is basically just we have one test that creates and destroys the table, and then a secondary test that creates one, adds a couple strings, and then verifies that they're correct and destroys it. And if we actually take a look at that, we have this run unit tests here for, let's see, actually we want core unit tests. Let's go ahead and run that. And so let's see, we do have a couple of issues in here we probably need to look at some point, but the one I'm interested in is all the way at the top, which is 1 and 2. 1 and 2 are essentially these tests. So I figured out most of those issues, and I think we are good to go as far as that's concerned. So if we go to launch the actual game itself, and we load, we actually get kind of where we were last night, but I want to just kind of verify that everything is as we expect. So the binary string table get is where our seg fault is happening, specifically with copying memory. If we take a look at the index, though, we have index 0, which is kind of what we expect, right? So if we go up a level here, and we take a look at the code, essentially when we are processing submeshes, as we go through each submesh, we go ahead and we grab the name for that particular submesh. And so the submeshes, we actually only have a single submesh in this. And so we could verify that by taking a look at the submesh count, which is 1. So if we come down here, we take a look at the name IDs. The index that we are currently looking at is 0, index 0. And we can also see that the name ID here is 0. So this should be extracting essentially the very first string from the binary string table.
Next month is my 2-year anniversary with Travis. Good memories. Worth it.
Holy crap, almost 2 years. Spiro, thank you so much for the support, buddy. How have you been? How are you doing tonight? Hope everything is going well. Let me catch up on chat while I'm looking. Spiro, it's great to see you. Thank you so much for joining. In fact, if you guys aren't following Spiro, let me do a... There is a shout out to Spiro. He's a good friend of mine. He is always streaming on Twitch. He does a combination of tech news, so he's always looking at the latest news in terms of the tech industry, and is always kind of reviewing that and giving his thoughts and opinions on it, which are generally pretty based. But then he is also on stream making a video game in where he is basically programming his engine in C, targeting WASM with that, and then using the HTML DOM as his renderer. So it's definitely a sort of out of the box tech stack. So I highly recommend you guys give him a follow if you haven't already. Definitely good stuff over there. Didn't realize TTS was going to get triggered. Yeah. Anytime you do a sub of any kind or bits over 100 bits, you get TTS along with that. So thank you for that. All right. RCW also has a 7 stream streak. Thank you very much for that. I greatly appreciate that form of support as well. So thank you for that. Got a streak going. Let's keep it going. Yes, I agree. So yeah, thank you very much for being here. Let's see. What is 10 plus 1? How's it going? Good to see you. Welcome. Let's see. I think we're caught up on chats over on that side. Singy over on the YouTube side. Good to see you. Barbel, good to see you as well. Is there a video or clip or whatever where you explain the renderer architecture of Kohi? Yes. I don't have a link handy though. But yes, we have definitely gone over that a few different times. I can go over it really quickly though. So essentially, and I'm going to kind of do this in a non-visual format, right? I'll kind of just do it verbally here. So our architecture, as far as the renderer is concerned, is we have what's called a renderer front end and a renderer back end. So the renderer front end is sort of the graphics API agnostic version of the renderer. So it's it doesn't care about whether you're using Vulkan or Metal or Direct3D or OpenGL, whatever. It is what the rest of the engine sort of interfaces with, right? So we have the renderer front end for that, and then the back end is what you would expect in terms of a renderer API specific implementation. So right now we have a single renderer backend that is Vulkan. Eventually we will have Metal and Direct3D as well, Direct3D 12 rather. And the way that is implemented is via a plugin system that we have. So we've got the renderer itself, or at least the renderer backend, is a plugin. And so that implements an interface, and essentially we can have the application choose which renderer we want to actually use. So at the moment, the only choice is Vulkan, because we kind of want to get to close to feature complete before we start to, stand up some of those other backends. So we're using Vulkan for now. The next one I'm going to make is going to be Metal. But essentially, the way that it works is all of the rendering requests through, or from the engine rather, go through that renderer front end. That gets taken into the renderer backend and translated into all of those renderer specific, render API or graphics API specific calls and whatnot. And then, those things are made under the hood and managed there. So there's sort of that abstraction layer that we have. And we've done that same pattern also for the audio system. So I hope that makes sense. Thank you so much.
9,668 donated 200 Brazilian reais through Super Chat.
Thank you so much for that donation over on the YouTube side. I really appreciate that super chat. Actually, I think that's one of the first one of those I've seen in a while, so I really appreciate that. Thank you very much. I appreciate that support. Siggy, good to see you as well. Looks quite robust. Yeah, it's coming along nicely. We have refactored various things, just trying to figure out what works, what doesn't work along the way. And we do a deep dive into those things when we find something that needs refactoring. We kind of go into, the good parts of it, the bad parts of it, the ugly parts of it, and why we need to refactor it, and so forth. So we do that all on stream. And any of it that I do off stream, I do, I call that offline, because sometimes just to kind of keep the project moving forward, I will do some work offline. But any of that I do, I do go ahead and review here on stream, even if I don't necessarily always write that code on stream. So let's see. I'm going to take a deeper look into your videos and source. Very interesting way of implementing that. Yeah, please do. You'll want to stick to the main branch. We are currently working on a release of 0.11. But that is far from complete, so you'll want to stick to the main branch on that, and hopefully that will work fine for you. I've got a lot of improvements coming down in 0.11, but we still have quite a ways to go before I think we're ready to call that one done, so to speak. All right. Always learning from the Kohi project. I appreciate that, RCW. Really appreciate the kind words there. So, yeah. All right, cool. So let's actually have a look at the tests. So essentially, we have the binary string table test here. All I did was I created a create and verify, destroy and verify, where we essentially verify the state of that table before and after creation and destruction. And then we've got a single test that creates and destroys that thing, and then a single test that creates, adds two strings, and then destroys it, and then, of course, verifies all that state along the way. So I think that is all fine. What the issue seems to be here is when we're looking at so submeshes name IDs index I, which is 0. So this is essentially saying give me the value of the first string, and that is where it is bleating. So if we take a look at entry length, that is 32,767, which is obviously wrong. So we have to figure out why that is. So I think what I'm going to do is let's take a look. So we know our tests are good. Our tests actually work as expected. So let me go ahead and do importer model assemp. And anything that we're talking about a name, specifically, I guess we should probably start off with, let's see. with, oh, interesting. Let's see, there's lots of names here. So actually, let's do kname, right? Or we'll do kname create. We'll do that search there. So let's see, from assemp. Okay, so this is the sort of import, if you will. So essentially, we take a AI scene, which is the assemp scene. We take in a package name and an output model to output all of this data to. The interesting bit about this is we actually process the bones first. And the bones actually are responsible for creating the K-names before we actually even get, way before we actually even get to the submeshes, right? We also do, so we do the bones here, we do the nodes here, and then we do the animation channels in the keys here, all of which have names of their own. And then we also extract the submeshes, which is sort of done last. So the fact that this is actually looking to get index 0 is a little bit suspicious here, just because I don't think at this point we should be dealing with index 0. So I'm wondering if we actually have something else going on here. So I think what I might do is I actually might go here and let's take a look at kname create, and I'm going to basically put a breakpoint anywhere that we are doing this, minus the package name. I think we can actually skip that one. Let's see, materials from assemp, animation asset from assemp, right? So I think this is probably the function that we're going to want. So here we're doing the bones, so I'm going to put a breakpoint there. Let me exit out of this. I'll put a breakpoint there. We'll go to the next one. Here is a node. We'll put a breakpoint there. And then here is a, let's see, what is this? This is a animation name. So we'll put a breakpoint there. And then a animation channel. So we'll put a breakpoint there. And then finally, the target, let's see, this is actually the submesh right there. So I'm going to run the application, and I want to see, oh, I need to, instead of this, I need to actually run the import process, because I want to see what actually winds up getting internalized here. So let's see, we have the name here. So AI bone mname data does have a right to base, and it is null terminated, right? So that seems to be fine. So we hash that and move on. That, I guess, is probably fine. Let's actually just, let's take this over and put it in our debugger so that we can kind of just see what's going on here. Resize this a bit. You know what? Actually, let me get rid of some of these breakpoints. We don't need all of those. Okay. Okay, so these are all bones. I think I'm going to disable this one because I think the bones are probably fine. And then come down here to the node processing. So obviously the nodes themselves also have, like we have root node there. And then we have, you know, the vampire there. And then the next one is we have the hips. Right, so it looks like we are extracting the strings out of here correctly, at least for now. So I'm going to disable this one as well. Move on. So now we have the animations, right? So we have a single animation here. And this is animation mname data. Is the animation's called hips, really? That seems kind of strange. But okay. And then we have the animation channel. And so this one also has the name of hips. So I guess that's the name of the animation or something. Spine. I wonder if this is actually wrong. Right, so anim mname data. So I wonder if this is actually just not reading in the thing correctly, but we'll go ahead and disable this breakpoint and disable this breakpoint. All right, and then finally we have the meshes, right? So the first mesh that we are dealing with, its name is vampire-lib. It looks like, yeah, lib. So that's kind of an interesting name for it. All right. And I think that's the only mesh that we actually have. So the next thing that we're going to have to check is, let's see. So we do the anim asset from assemp, and then we should probably go to the serializer and debug that, right? So the first thing that we do in the serializer is we create the string table here. And then here is where we actually go through and add some of the names, right? So this particular thing here is for the submeshes. So let's actually put a breakpoint here and here. And then for bones, we'll actually do the same thing. I suspect we've done something probably stupid in our code. So we'll do animations, and then we'll do channels. Okay. All right, so we will go ahead and run this again. Sit tight, chat. This is some coding going on right now. Yeah, exactly right. Working for someone is weird sometimes. My platform layer got denied, and I was told to use SDL3. Not reinventing the wheel, yet they are having me code them a custom game engine. Seems dumb to me, but they write the check, so I'm not complaining. Yeah, that's genuinely the attitude you want to adopt, right? Like, if that's what they want, do what they want. Suggest things where you can, but like if they are adamant about it, do what you gotta do, right? At the end of the day. That is a little bit weird. Like SDL is great, right? Like SDL is battle hardened, battle proven, you know, like it's a fantastic library. But if you've got one that does everything you need, that's a little bit bizarre that they would deny that. But maybe they don't want bugs, but like SDL has bugs too. So I don't know. It's a bit of a delicate balancing act with that sometimes. Let's see. Pixel Catcher over on YouTube. How's it going? Good to see you. Bashir, good to see you as well. Making game engine using STL3 GPU API and is going super great so far. That's awesome. Looking for a good and complete Vulkan book. Any suggestion? Vulkan programming guide seems solid, but it's quite outdated. Unfortunately, the only book that I have that I've read through is also outdated, which is the Vulkan cookbook. I have the first version of that I bought when Vulkan came out. And so, yeah, that's pretty outdated. Nowadays, if I have like a question on how to do something in Vulkan, I just look at the spec, quite honestly. And that usually kind of gives me, well, okay, so I look at the spec, and then also the examples from Sasha Willems are pretty decent as well. They're a good starting point, right? There's issues with those as well, but depending on how you're going to use them, because most of those examples are kind of built around a what I would call a model viewer, right, where you have just a sort of single model that or a couple of models in the screen that you sort of rotate the camera around. And it's not really something that you would necessarily want to base a game engine off of, but a lot of it is like, here's how you use this particular feature, and that's usually enough to act as a springboard into a full implementation on your own. Anyone remember GDI Plus? Yes, I do. Haven't touched it in a long time though. PC only supports Vulkan 1.3 and wants to switch from OpenGL to Vulkan. Do you recommend me do that or not? I would still say yes, because Vulkan 1.3 is actually pretty decent, I would say. And technically it's not your PC that supports it or not. It's actually your GPU driver. So it's possible that your GPU driver is out of date, or if you're on something like a laptop, you might be kind of stuck. But you might be able to just update your driver and get the newer sort of version of Vulkan if it's been implemented for whatever GPU you have. But yes, either way, if you're on 1.3, that's definitely sufficient to do 99% of what I've done here. Let's see. You have Vulkan Cookbook as well? Yeah. Yours has Vulkan 1.3. I think mine is... let me see. I want to say this one is 1.0 or 1.1. I forget exactly which. It's this one. Which, this has some decent stuff in it, but it's kind of outdated now. Because a lot of the stuff in 1.0 or 1.1 you don't necessarily need to do anymore. Although it may be good to sort of understand some of the other things that the newer versions do for you or include for you. Let's see. Does this actually say? I don't know if this actually says in here anywhere what version it uses, but I'm pretty sure I think it's 1.1. It's either 1.0 or 1.1, I forget. But like this one even goes into, like this one was written before the Vulkan loader was written. I know that. Yeah, I'm not 100% sure. Yeah. But either way, it's got some decent stuff in it. It's just, if you can find an updated version, cool. I have not looked into it rather. Let's see. I said PC because it's laptop and I can't change the GPU. I have to upgrade the whole PC. Yeah, so laptops you might be stuck. Unless, whoever made your GPU, whether it's NVIDIA or AMD, actually updates the driver, you might be stuck on that. But like I said, 1.3 is actually pretty good. pretty like you'll have most of what you need in there, if not all of what you need. Make your own driver, right? If only. If only. Odd, especially if it's a custom engine. Maybe they're concerned about future maintenance. Yeah, that could be a concern, right? But like, how often does that stuff change at that level? Like, almost never. The tests are green and the check clears your bank, then hey, that's a thing. Yeah, exactly. Yep. 100%. I was reading through the Vulkan spec earlier and told my wife I was doing a bit of light reading, and then she noticed how many pages it was and just sighed at me and walked out of the room. Yeah. I can't imagine mine would have too much of a different reaction to that. I think if I were to show her the Vulkan spec, she would probably just like nope on out of the room. And I can't blame her. For sure. All right. So we do a K-name create here. So target is submeshes, right? So we do create a K-name. And that is a non-zero name, so that means that the hash worked correctly. So the only thing that I can think of is maybe, even though that we're creating this name, maybe we are not adding it to the string table. We should be. So the real question is, well, this is just animation asset though from assemp. So we actually don't even have a string table at this point. All right, so we know that that's being added. So the importer then when we go to serialize, right? This is anim asep from assemp. So I suspect this is working correctly. So maybe the issue is actually here. So the serializer oops, 470. The serializer might not be doing what we expect it to do. So submeshes, let's actually do a breakpoint there, right? We do have submesh count, okay, so we can get rid of that. And then we can go into the individual submeshes. So here is where we do submesh counts. We do the vertex size and the index size. We calculate all that up to create the buffer. We add the total block size, and then we loop through them again. Here we go, name IDs. So let's actually move this up a level. And we'll say submesh name. Okay, so that's non-zero, right? So that should be vampire lib. Okay, so if we have a name, then we should be doing a binary table, string table add, and adding the name. And then whatever gets returned from that should be applied to the name IDs sub I. So I guess let's go into that. We'll step into that real quick. So new entry, string length, offset's the first string that makes sense. Length is 11. I think that's correct. Yeah. Okay. And then we do a realloc on the table data. So the table data right now is null pointer. Block size is 0. That's the old block size. And then we have the new entry dot length. So we should just have now a non-zero we need to add the data block size. Okay. And then, entry count is not updated yet here. Okay. So table data. Oh, this might be another. No, that's actually got a type on it. Okay, so table data plus new entry offset, which is also 0. So we copy the memory from the string at the new length. So that should be that is 11. Okay. So we copy that into the table data's memory. And then we say DRA push new entry, which is this guy right here that tells us where that is in the actual block. And we do entry count is equal to DRA length of the table lookup. So that should be 1 now. Yep. And then the index is also the last entry. So we say entry count minus 1, which would make it index 0. Okay, so that seems correct to me. Okay, material name ID is 65535. That's max U16. I should have broken on this breakpoint. I don't think... Is there not a material name with this? Submesh name. Submesh material name. There is no material name. Okay. That might actually be an issue. Okay, so that means that is going to be a null pointer, which means we are going to default to invalid ID U16 for the material name. Okay, so that actually does make sense. Okay. So I wonder at this point, bone name IDs sub I, that should have been 1. Okay, so that is correct. And then 2. Right, so for each of the bones, that increments. So that actually looks correct, so I can kill that one, I think. And then go to the next one. So this should be nodes, name IDs, sub I. And so this one is equal to 53. Okay, I guess that's accurate. That's still incrementing every single time, so that looks good. And then animations. So animation name is just that, right? So that's going to be 120. Okay. So that seems fine too. We have a single animation. That is fine as well. And then channel name IDs. So I think all of this logic is actually good. Do one final check here. 121. Okay. Yeah, I'm convinced that this is all good as far as the importer is concerned. So that leads me to believe that perhaps there's an issue with the serialization of the string table. So if we go into that, let's see, total size is the size of the binary string table header, which makes sense, plus the size of the table entry times however many entry counts we have, which is 173. And then we also add to that the data block size, which is that. So that's actually all of the raw string data. So we go ahead and put that in there. We allocate the total size. We copy straight to that the table header. So that should be fine. Lookup offset is the size of that. That's fine. Copy type array. So lookup offsets is that. Table lookup. Entry count. So I guess that is also fine. Lookup offsets. Table lookup. Binary string table entry times header entry count. Okay, so that actually looks like it's also doing the thing correctly. Data offsets is the lookup offset, which is the header, plus the size of the table entry times the entry count. So I think that's fine. Okay, so we have data offsets. So this is where we copy into, and then we have table data. And data block size. And then total size is here, which is all of this stuff combined. Okay, so I don't see anything here that looks wrong. So we allocate to that, and then we do all of the right binary stuff. Down here at the bottom, we finally do a write binary to the block of memory, the serialized string table, the offset, and the string table size. Okay, so the serialization, I think, is correct. I wonder if the deserialization of this is just wrong. Destroying the table shouldn't matter because you take a copy of that memory. RCW, your message got timed out, but I will. I'll read it anyways. Feel that way about real-time rendering. It is a thick one, yes. Let me see. Reading through the Vulkan spec earlier. Oh, wait, I already read that one. Okay. It was funny. I'm working with the DirectX 11 as my renderer, literally reading through this book for fun, or because I hate myself. That's fair enough. Feel the same way about real-time rendering. Yeah. I have that one. This one is indeed thick. I've got bookmarks in it, as you can see. That's 2 C's thick. Bordering on 3 C's thick, actually. But yeah, it's a thick one for sure. It's definitely thicker than the Vulkan cookbook, that's for sure. If you compare those two, it's about twice. But yeah. That one and game engine architecture are pretty thick. Real-time rendering is next on my list to get, but that book is so expensive. Yeah. I actually picked up a used copy. I picked up a used copy of that, and I picked up a used copy of game engine architecture because it was a little cheaper to buy it that way. Straight off the old Jungle website, you can find used ones there sometimes that are a little bit cheaper. But yes. I'm actually due to read through this again because I've read through the game engine architecture one somewhat recently. I'm actually due to read through this one again, and that's just the book we're talking about there. In case you weren't aware of that. Okay, let's see. Like the colorization of the syntax highlighting, not too colorful, just right. Yeah. Well, are you talking about this window or are you talking about back here? Because this one is actually the one I prefer. This is just sort of my debugger here. Which I've tried to get to match the color scheme, but it's not exactly the same, unfortunately. Anyway. Where was I? So we serialize all this stuff. We write out the... Oh, wait a minute. When did we actually serialize that table? Here. Yeah, that should be fine. Okay. All right, so we serialize the table, we write that out, and then when we deserialize it, I suppose we should probably actually debug that, right? So let's do a from block, right? We'll debug this guy. So let's go to switch to launch. Right. Obviously, we have the block of memory, so that's not an issue. Okay, so let's see. The temp should be just the header, right? So the data block size is 2063. Entry count is 173. So that, I think that's what we had before. And then we go ahead and grab the offset for the lookup. And then we go ahead and we do essentially, so this temp table here is a lookup, or is a cold cast rather, from the block plus lookup offset, right? So this should be an array. Yeah, see, that's not right. So something we've done here is wrong. Okay, so let's actually double back to this. And we'll go to here. And there are two functions here, right? So the serialized is essentially what takes the binary string table and writes it to a singular block of memory that we can then write to a binary blob. So we do, let's see, we grab a total size. So we have the size of the header, the size of the entry times entry counts, and then the size of the header data block size. Okay, so whoops, that's probably fine. Whoops. Okay, so that's probably fine. Out block is, let's see, we're going to allocate that total size, and then we are going to copy the type, table header, binary string table header. We're going to copy that to the out block, the first bytes of that out block. So that should be fine. And then the lookup offset is after that table header. And then we go ahead and we do a k copy type C array. So our destination is our out block plus our lookup offset that we got here. Source is next. So the source is going to be the table lookup, which is an array of those binary string table entries. The type is binary string table entries, and then the count is the table header entry count. So that seems fine. And then we do the lookup offsets plus the size of that table entry struct times the entry count. And those are all scoped here. So that looks correct. Yeah, and then we do out block plus, plus data offset, which is this guy here. And that's where we actually write the table data and the data block size. So that bit seems fine. Let's check the other half of that. So when we go to, say, from block, right, we basically just take in a block of memory. We say, okay, let's grab the binary string table. Oh, wait a minute. Wait a minute. I think I see what I've done wrong. This shouldn't be that way at all. This should be the header, actually. That should be the header, right? Because the header is the first thing within that block, right? So we should do header here. Then the lookup offset is going to be after that header, and then the table this should actually be up here. Let me see what this does real quick. D-array creates. Okay, I think that should be fine. So actually, technically, we should have table header equals dereference header. Right, so we take a copy of that, and then the lookup offset is past the header. So temp lookup is going to be this should be table lookup. Oops. Let's see. So that should be binary string entry. So that's going to be block plus lookup offset. Okay, so that should be that. And then data offsets is going to be header entry count. And then we have table data is equal to that. Yeah, and that actually that should be all that we need, actually. Right, because we go ahead and we set the header. Let's see, header. The header is that. So the entry count and data block size, those should directly come out of the block of memory. So I'm thinking, actually, we're just using the data directly here, though, which we probably shouldn't do. We should probably take copies of all this stuff. Annoyingly. We do that for the header. The lookup, however, we should probably do k copy memory. And then the destination is going to be table lookup. And then the source is going to be that. And then we want the size of binary string table entry times header entry count. Right. And then this, I think, this, I think, just actually doesn't. All right, so table lookup. Why is this complaining? Has no effect. Okay. Oh. So we have destination source, which I guess doesn't even need to be that. We could just do a void pointer at this point. So that's going to be block plus lookup offset. That should be there. Oops. Get rid of that. Okay, so it should be destination source size. So destination source is after lookup offset. Yeah, and then size is going to be the entries times the entry counts. Okay, so we take a copy of that. And then the data block, we're going to do the same thing. So we're going to say k copy memory. Right, the address is going to be table data. That's going to be the destination, rather. And then data offset, and then the size is going to be header data block size. What am I missing here? So I don't need that. It should just be that. Okay. So I don't need any of this stuff. Let's see, table lookup. That is actually important. So table lookup needs to come up here. Right, so we reserve that space. And then the table data needs to be allocated. So we do that here. Data block size. Right. Okay. And then we should, we need to also set the length of the array up there. And then this I can go do away with that rather. Take a copy of the incoming data. Okay, so is this, maybe that's what we need? Might be missing something. Diminished, how's it going? Good to see you as well. I'm doing all right. Thank you for asking. Although I disagree with your opinion. If you know what I mean. Okay. Appreciate the compliment, though. Even if I disagree with it. Okay, so let me run this. So I think let's actually continue past this. Index is less than table header entry count. Okay, so where do we hit that assertion? Something tells me we're still not quite doing the thing correctly. So entry count is 173. Index is invalid ID U16. So why are we getting that? Material name IDs. Ah, that actually, okay, so we did move on. That should be submeshes. There we go. Okay, so I guess what we should probably do is let's see, that was what, 346. Wait a minute. KSet importer model and importer asset 346. How is that possible? Oh, because I'm looking at the serializer, that's why. What was that line number again? That was 346. Okay. So, there is the possibility that these things don't have names, right? So, I suppose we should probably do if submeshes material name IDs sub I is not equal to invalid ID U16, then we'll want to do all this. And theoretically, we should probably also do this for the name, right? So we'll do if submeshes name IDs sub I is not equal to invalid ID 16, then we'll do this. Not sure why there's not a material name, but it's not necessarily required by our format, so see where we get. All right, let's see. Release model. Okay, that's interesting. So let me just verify the logs here. Well, it looks like it did the thing. Okay. Outside of allocator range. That's interesting. Been following for a while. This is the first time I've gotten Twitch to work. You've been streaming, so this is great. Started my own engine, and once I saw how much fun it looked like you were having, I've learned more in the past couple months than I have in a while, so thanks. Awesome. I'm glad to hear that, and thank you for the kind words. I greatly appreciate that kind of feedback, because that lets me know that what I'm doing is valuable and useful. And of course, you know, if there's feedback to the contrary, I value that as well. But yeah, thank you so much for that. Appreciate that. Okay, so why is this? Why is this bleating? We have both of these things. Platform free. Why is that outside the range of our allocator? That is bizarre. It definitely should not be. Saying the range of this. Well, that's because it's rubbish. That's why. CH positions. Okay. So why is it rubbish? Right, because we don't actually have any data in there, which is... It's fine. Seems fine. Why do we not have any data in there? Okay, so is it another instance of like a off by one type of thing? Asset system release model. I feel like we need to look through that a little bit. Okay. So we have our K-asset model. This was in particular bleating at within our animation channels. Okay, so that would be right here. Did I screw up any of the loops? It's highly possible. Let's see. Submeshes. Actually, was that? Yeah, okay. So it got past this. So the vertices and indices from the geometry for each submesh, and then we nuke the submeshes array. Oh, excuse me. And then let's see, we have the animations and animation counts. So we loop through those. And then this is the animation channels. So we have animation sub I, channels sub C. Okay, that does make sense to me. So why is this not correct? I suppose what we should probably do is, like, if we run this, we should probably do, ch positions equals 0. That kind of thing, right? Ch scales. Let's actually, you know what? Let's use the new k-null thing that I put in place just to be a little bit more explicit. Ch rotations equals k-null. And we should probably also do ch.position counts equals 0. Because I wonder if we're like trying to double free this somehow. So ch scales scale count equals 0. And then whoops. Ch rotation count equals 0. Okay. So once we do that, then we nuke the channels array. And then after we complete that loop, we nuke the animations array. So we should probably do, well, I guess we should probably do this, right? I'm not bothering to do it here because that, well, okay, I guess I could. Just to be explicit, right? Like this pretty much immediately gets clobbered as soon as we do this, but there we are. Submesh data, like the same thing is true here with this, right? So we could do asset submeshes equals that, and then asset submesh counts equals 0. Here we could do asset bones equals k-null, asset bone counts equals 0, and then asset nodes equals k-null, and then asset node counts equals 0. Equals 0. And then we free the asset model. Now, I don't think that any of that was the issue, but it will help us if we try to double free it for some reason, which we might be actually doing. I think I can kill this one. All right. So, yep, same thing. So positions and position counts. Whoa. There's no way that's accurate. So that makes me think that we may have an issue elsewhere reading this in. So if we do release model, let's see what the asset says about all of its various things. So submesh count is 0. Is that because, though, do we already... Yeah, we've already zeroed that out. Okay. So... Release model. The asset itself. So submeshes has been set to 0. Bone count, node count, animation count, animations. Okay. So why? Jeet, how's it going over there on the YouTube side? Good to see you. No, I still haven't switched to a 2E. I'm not fast enough with it yet to make it worth doing on stream. I've been experimenting with it a little bit, but I'm not fast enough to switch to it yet. It's kind of like where I was at with Vim a couple years ago. Don't think I'm quite good enough to be giving feedback yet. Still have to look up the syntax for structs occasionally. Yeah, I mean, that's fair enough. We all start from somewhere, right? Don't worry about that stuff. Like I said, I appreciate the feedback one way or another. So if you find it useful for some reason, or there's something that bothers you about it, feel free to speak up. I'm open to criticism as long as it's constructive, right? So why then? Because this all looks valid here. So why is this? Why is the position count so wildly out of whack? Animation count's 1. Channel count. Let's see what this channel count is. $52. Okay, and then oh, I see the issue. You guys see the bug? It's one we found last night too, somewhere else. Dang it. Dingus-oriented programming for the loss. It is right here is the bug. So 731 in our asset system. We are basically looking at the channel count as our conditional, which is always going to pass. So this loop is just going to continue in perpetuity. So this should be C is less than channel count. And wouldn't you know it, it's another place I'm using C++. Dang it. Every time I go to use C++, even if it's as an iterator, there's a bug. What a dingus. What a dingus. I mean,
I knew this was gonna happen.
All right. Let's build that. And let's run. Needs more templates. Oh, no. No thanks. Do not want. Hey, we're running. It doesn't exactly look correct, but we're running. Which is awesome. So, that means a couple of things. I know that we don't have everything hooked up yet to actually display the animated mesh, which is fine. But that means that we were able to actually load the animated mesh without relative issue, which is awesome because that's a huge step in the right direction, right? So now we can actually load those. We're not doing anything with it yet. We still have to hook up some of that stuff, but at least we can load up our scene. And it looks like I'm guessing we're probably not using the correct shader in some instances here, because it does look like, yeah, it does look like we might be like using the wrong shader somewhere along the way. I'm thinking we might be using the animated shader, the animated mesh shader rather, where we should be using the static mesh shader for these things, and that's why they're not showing up correctly. Because notice we're not getting any sort of textures or anything on any of this stuff. Okay. So I think what I'm going to do at this point is, since we're actually at a point where we've been able to create our formats, import it, load it up, even if we're not using it yet. We have the importer working. We have the system's at least relatively hooked up, although I do want to do a little bit of work to combine some of those things. I think this is a good point to stop and check in what we have before we actually continue any further. So let's do, because we've done some work. Most of this is actually assets, which is interesting because we've actually, you know what? Let me look at some of those assets because I think I know what actually has changed with them, but I want to double check. So if we take a look at, actually, we'll just look here. Oh, you know what? I want to delete. I don't want those. Let's look at some of these materials. Yeah, this is where we added in all of the mapping stuff. So to bring our materials up to date after the material changes that we put in, these materials were all regenerated. So I am going to check those in. Okay. Let's just do that one more time. Do we have any no check-in stuff? I don't know. Let's say K3D model format importer and loader code complete. Still need to hook into engine for rendering. All right. So we're going to do that. We'll push this. And mind you, this is to the 0.11 branch, right? And then I'm also going to do really quickly. I'm also going to do a push on we had to update our ItemDB editor as well to actually include the new asset magic number, which is not a huge deal, but it's there. Updated assets magic number for ItemDB. Okay. Cool. So that's done. So now we can actually start on the debugging process of first off figuring out where in our render we went wrong in terms of trying to render things. So let's take a look at the Illumina renderer. And let's see, I think we want static mesh shader. Let's see, do we have animated mesh shadow map shader? Ooh, right, I forgot about all the shadow map stuff too. So this brings up another change that I was thinking about making. And I'm really debating if we should just pull the Band-Aid off and make it now, or work around it for now. One way or another, I'm going to have to make this change, though, I think long term. So, what I am referring to is, let's see. Where is... Vertex 3D. Let's actually do skinned. And we'll do, actually right there. Okay, so where do I begin with this explanation? Okay, we have two different types of geometry now in the system that we can potentially render when it comes to 3D objects. We have the Vertex 3D, which we've been using for literal years, right? So this is sort of the de facto vertex format or vertex layout when it comes to 3D geometry. So it's got position, normal, texture coordinates, color, and tangents. So this is pretty much the gold standard as far as the engine goes, as far as vertex data. When we're talking about animated meshes, though, or animated models, whatever you want to call them, we need slightly more information. So we need everything that is in a Vertex 3D, so position, normal, texture coordinate, color, tangent. But we also need information about bone IDs and weights, right? So that's basically saying for each of the bones, or for each vertex, we need to know what bone it's bound to and the weight of influence for that. And so, we can have up to 4 bones and up to 4 weights for each of those bones. And we basically just need to know what those are per vertex. The problem with this is this greatly fragments how we actually have to render these things. So we have to have a complete set of shaders for Vertex 3D vertices, right, that only include this data, and then we have to have a separate set of shaders and graphics pipelines and all that stuff for one that includes also this data. And that's where the problem comes in, right, is because we have a lot of this duplicated shader code, and then there are subtle differences, at least in the vertex shader code between the two, but the fragment shaders are identical. But we still have to have different graphics pipelines for those things. We still have to have, load up different shaders. We still have to handle them differently. We also have to context switch shaders back and forth, or at least in terms of Vulkan, we have to context switch which pipeline is bound, whether we're using one for skinned vertices or whether we're using one for just regular vertices. And so there's a couple of ways that we could tackle this. We could continue on with what we're doing now, which technically will work. And the biggest drawback to that is all of the duplicated stuff that we have everywhere, which I'm not really a huge fan of. The other way that we could potentially handle this, because right now we have a vertex buffer and an index buffer, is we could actually split this into 2 vertex buffers. and then of course an index buffer. So we could split up essentially all of our vertex data into standard vertex 3Ds for our skinned meshes, and then also have like a second structure of vertex data, like additional vertex data that includes the bone IDs and weights on top of that sits in a separate vertex buffer. And the advantage there is that would actually allow us to use the same pipeline for static geometry versus animated geometry. And the way that we would handle that is we would always bind 2 vertex buffers. But for static geometry, we would essentially bind the standard vertex buffer and then just somewhere in a dummy vertex buffer for a secondary that would essentially just bind to nothing and not actually be used. And then for skinned data, we would actually bind to the proper buffer with a proper offset to retrieve this particular data. So we'd essentially be splitting that in 2, right? So we'd have like an additional vertex data, or maybe a skinned vertex buffer that would include data such as this. And then when we go to actually draw, we would bind both of those vertex buffers and draw them. And those attributes would all essentially be put into place that way. So you'd have one set of attributes that would go in this way, and then immediately after that, you'd have these 2 attributes. And that's kind of what I'm leaning towards wanting to do, although it's a lot more work. But I feel like it's going to make things a little bit more flexible in the future. So I haven't really decided what I'm going to do with that yet. I may wind up getting this working just as is for now, and then kind of separately biting that off as a separate chunk of work to do. But just be aware that that's coming down the pipeline. Let's see. Let me catch up on chat. Debugging is hard. Yes, it is. Let's see. Quick question. What was the need of creating a custom file format for Kohi? I'm assuming KMT is a custom format just for Kohi. So KMTs are for materials. And so we have all of these. Let's see if we can find a decent. I guess we could look at, that's kind of a crappy example. I guess it doesn't really matter which one I choose. Let's go with this one. All right. So it's basically a format that allows us to define material information, right? So we can choose all sorts of properties per material, and then we can assign the inputs, like what's the base color, right? Are we using a map, or are we using just a solid color? In this case, we're using a map, and then, what's that resource name, right? So this is an image resource that will be loaded. Here's the package that exists as part of it. And then we have sampler information. This is all default sampler information, but we can include it and change it if we wanted to. And so, we just have all of these different options in here to allow us to configure an individual material. There are other proprietary formats that we have, like textures themselves and obviously model data that we've been looking at here. And the advantage there is we can actually set up our models in such a way, or our model files in such a way, where we can read from them very fast. We don't have to parse some crazy file format like GLBs or OBJ files or something like that. We don't have to go through all the steps of text parsing and building up a geometry that way. We can use our importer to build all of the structures the way that our engine expects it, or at least close to that. And so it makes loading those things much, much faster. And so that's generally the reason that we go for proprietary formats, is because we go the goal is to get that as close to the format that the engine expects, so that when we read that file, it's as direct of a transfer from file to, on disk to memory. So that's generally the goal there. And so that's regardless of any of the formats that we've made. Some of those are better than others, right? Like obviously the material format is still text parsed, but we didn't have any sort of format that gave us that capability before that. So that is a format that is human readable, that's very easy to understand, easy to hand roll those if you wanted to, and also easy to output from an editor later on when we get to that point, and we definitely will get to that point. How much time do you usually spend on your project per day? So this is a part-time gig for me, right? Less than part-time is what I usually say. So usually I get in, I would say maximum of 10 to 15 hours of work on this a week, right? Because I do have a full-time job. So this is not something I'm able to work on, 40, 50 hours a week. It is something that's part-time for me. Okay, cool. I'm glad that made sense. Let me check on the Twitch side here. C++ is the devil. Sometimes. Trying to use your project videos as a guide, but I'm intentionally designing things in a different manner because it makes more sense to me, but also because I don't want to just end up copying stuff. I want to learn as a guide. Your stuff is great. I have an idea of what I want to work on, what to think about now to help further down the road and such. So for me, it's invaluable. Okay, so you nailed it on the head, right? Diminished, you absolutely have completely understood the purpose of what I'm doing here. So it's the whole purpose of this is to show you a way of doing it, not the only way of doing it. And the idea here is to take this as inspiration and run and do your own, run with it, do your own thing with it, learn from it, use it as a resource, use it as a reference. But yeah, you're absolutely correct. Just copying this verbatim is not going to really teach you anything if you don't understand the concept. So, I'm glad that you totally got what I was after there. And that's awesome. That's the way that this whole project's meant to be used. So awesome. Let's see. We had this kind of bug yesterday. Triggered my thank God we found the bug. Now I'm going to make sure the same class of bug isn't anywhere else instinct even harder. Yeah, exactly, right? Large code base may be hard to do, but this might be an okay heuristic. Oi. That is a crazy regular expression. I mean, I guess it's not that crazy, but regular expressions, whenever I read them, always break my brain for like 2 seconds. Searches recursively for for loops with a condition that does not have a less than sign. Yeah. Actually, yeah, that's actually, you know what? I'm going to copy that one down. Because that is useful. And for those of you who are wondering that don't have access to the chat, this is the regular expression that RCR put out there. Let's see. Sounds like it's time to fire up the good old refactor tractor. I mean, yes and no, right? Like, I kind of want to get this feature more or less complete before I do that. Baguettes, good to see you. Started using typedef struct ss, struct s, blah, 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 convention with my structs. Yes, it just works, right? It works really well. Using this, typedefing your structs this way just makes it easier to use in code. And if you have to forward declare it, you can still do this using the same name. You don't have to do the whole _t thing. So yeah, it just works really well. I've been doing it for a number of years now, and it works in every circumstance, which is awesome. Let's see. Mason, how's it going over on the YouTube side? Hello. Nothing about a regular expression is regular. Seems so irregular to me. Yeah. Yeah. It's like a whole thing. It's like black magic, basically. At least that's kind of how I look at it. I mean, I have a rudimentary understanding of it, but I'm always having to look that up anytime I have to use one. Point is to do the type defting first, then the struct itself, so I could macro it. Define struct name, type def, struct name. Oh, that's fair enough, Magets. Yeah. Fair enough. All right. Let's see. We only have a couple minutes here, so I actually think at this point in the stream, this is actually probably a really good place to break, because I'm not going to be able to jump into anything that's going to be too crazy to be able to work on. I guess I could look at the Illumina render really fast and see if I can't figure out something as far as why it's drawing funky. It's probably going to be a render frame. Shadow pass, it's not going to be the shadow pass. It's going to be after that. Maybe we can squash a bug really quickly. We'll see. Okay. Oh yeah, the reflect and refract passes were also foobar, if I remember correctly. Do we... Okay, here's scene pass here. So let's see. We do skybox first, which I think the skybox was animating correct, or was rendering correctly. Let me verify that. Yeah, skybox is fine. Okay, so skybox was fine. Mesh begin render. Okay. Let's see. Where did we actually use material renderer? So the material renderer, oh, that might be a problem too. Okay, let me go to draw geolist, right? Because we have the static geometries and then animated geometries is what we have in here. And we have two different lists for each of those things. So if we do this, actually, I wonder if I just comment that out for now. I doubt that's going to fix the problem, but it's worth a shot. No. Okay, I didn't think so. I suspect that's probably part of a larger issue. So this is part of the problem, is we would essentially have to, the way that this would have to work, stepping through the whole frame here. We have a scene pass, right? So this scene pass can be executed in one of three ways. It can be either what we call a standard pass, which is essentially rendering the scene normally. It can be part of a refraction pass, which means we are rendering the scene below a clipping plane. For use later as a refraction texture for a water plane, right? So we, as you look through the water from the top down, everything after that will be refracted, right? And then a reflection pass, which is essentially the opposite of that, which is everything from the water plane or a clipping plane upwards. And so we have each of those passes, and then within those passes, we have we render the skybox. We have to render all of the static meshes first. The opaque ones, and then we would have to do the animated meshes, the opaque ones, and then we would have to do the static transparent meshes and the animated transparent meshes. And the problem with that is there are several shader context changes that have to be made. So the skybox is one shader. That's not really that big of a deal. The static meshes are one shader, right? So whether you're doing opaque or transparent, that's one shader, right? So we'll say skybox is shader A, static mesh shader is shader B, and then the animated mesh is shader C, right? And so essentially what that means is to go through the order that we had listed there, we'd have to do bind shader A, do the drawing, bind shader B, do the drawing, bind shader C, do the drawing, then go back to shader B, do the drawing again, and then back to shader C and do the drawing again. And so there's lots of, and that's, we would have to do that for each individual scene pass, right? So for every water plane, that means that's 2 additional passes. You have one for refraction, one for reflection, and then of course the standard pass. So if you can imagine, if you have a couple water planes, that drastically increases things. And so when I start thinking about that, I'm like, maybe it makes more sense to kind of unify things into a single shader, and use multiple vertex buffers instead of having all of those changes, all those context changes or pipeline changes for all the different shaders, right? So that's kind of why I'm going back and forth on that now. I can read C, but to me, verbosity isn't like some clarifying factor. I mean, I guess fair enough, right? Fair enough. All right. Mega shader. Yeah, I mean, it is essentially going to wind up being a mega shader. When my code gets bigger, my brain confuses how to handle that. That's a good question. There's not necessarily always a one-size-fits-all solution here. And you've actually, if you've watched the stream for any amount of time, you've probably actually seen me going like, whoa, I haven't looked at this code in like a year. I just have to refresh my memory on it. And that's just kind of the way that it goes, right? The more, I mean, this code base is around 74,000 lines of code at this point. So it's a little tough to keep it all up here. Sometimes I have to refresh my memory on some things, but generally speaking, if you write and understand all of the code yourself, and you're not just copying it from Stack Overflow or ChatGPT or something like that, and you actually understand what you're writing, that understanding will stick in your head much better, generally. All right. All of that being said, it is unfortunately time for me to end tonight because I do actually have work in the morning. So let me find somebody to raid. And while I do that, if you are new here and you haven't already, I would greatly appreciate a follow on the Twitch side or a sub on the YouTube side, or both if you are so inclined. It would greatly help me out. Thank you for that. And yeah, I'm trying to grow the channel, both of them technically, just trying to reach more people, and hopefully inspire more folks to get into some of this low-level stuff, create some awesome tech out there that isn't reliant on the big three, and hopefully even make some competition for those guys. Thank you again for that follow. And let's see, we are going to raid. Trying to decide who I want to raid. Bear with me just a moment here. I have a couple options here. Let's do... Trying to look for something that's kind of loosely related to what we're doing. Nope. Okay, not that one tonight. You know what? We rated him last night, but I'm going to rate him again tonight.
You dingus.
We are going to raid Step Henny 0. It looks like he's working on a physics engine. His renderer is OpenGL. Looks like he's got about 3 viewers now, so we're gonna try and step that up for him a little bit. He's coding this in C++, and it looks like he's making a physics engine from scratch, which is kind of a cool project. So let's go show him some love and some follows and all that good stuff. And yeah, I will catch you guys on the next one. Thank you guys so much for being here. I really appreciate you guys. Thank you for all the follows and the support. And I will catch you guys on the next stream. So yeah.